All right, all you online math learners, we're going to look how to evaluate inverse functions. I got a whole classroom of students right here, and they've been already taught this, so they should know all these answers. They're going to be like, this is super, super easy. So first thing we're going to talk about is what inverses are. When I say f of x, that basically means, hey, that's your x value. We're going to be looking for the y value that goes with that x value, okay? So this is your domain, and you're looking for what's called your range. However, if I say what is the inverse of x, now you got your range and you're looking for your domain. That's basically all it is. So let's do a quick little test right over here. I know my students are going to get it. You may not, but that's okay. I'm going to say, what is f of 10? What's f of 10, everybody? And they say 14 with great enthusiasm. Okay, but if I say, what is the inverse of, let's say, 7? Oh, wow. Well, how'd they do that? Well, the first one, they said f of 10. That means you plug in a 10, you get a 14. But this one means, hey, if you go backwards, if you start at your y value, you go back to your x value. Now, something we learned yesterday is that the inverse of f of x always equals x. So if I were to say the inverse of f of 1, 2, 3, 4, close it. What's the inverse of f of 1, 2, 3, 4? 1, 2, 3, 4. All right? If I say the inverse, some people that's enough, some people it's just not enough. All right? If I say the inverse of f of a, b, c, what's the answer? A, B, C. It's easy as. There you go. All right, so over here, this one you'll notice, do you guys see 6.022 anywhere on this table? No, but this says the inverse of f of that, so it's just going to be whatever it is. Right there. All right? Now, if I say, what's the inverse of negative 10, what are you guys going to say? Negative 6. But if I say, what is f of negative 6, it's negative 10. So we got to add those suckers together and we get negative 16. So remember, this one, what are we searching for? We're looking at the y values and you're going to your x values. Here, you're looking at your x values going to your y values. This is a great example. I wish all the examples would just start out just like that because we could easily get this done. All right, so here we go. We're going to type in 6.022, and then what do we type in here? What was that again? Negative 16? Negative 16. All right. All right. Woohoo! All right, now, this one is kind of a cool graph here, all right? So we got these little, we call them widgets. We can kind of move wherever they want, okay? All right. All right, so basically what we're going to do is we're going to take a look at this ordered pair. What is this ordered pair? It's at a 1 and a 9. So if it's at a 1 and a 9, I got to plot a 9 and a 1. What's this point right here? Oh, hold on. I need to pause the video because people are talking while I'm talking and I got to gripe at them. Okay, so now we're back. All right, I said very politely to stop talking to my class. All right. All right. So let's see here. We got a 3 and a 2, right? 3 and a 2. What's the inverse of a 3 and a 2, everybody? A 2 and a 3. So I got to plot 2 and a 3. Now, interestingly enough, do you know what inverses always reflect across? Do you guys know what inverses always reflect across? Do you know? Do you know? Do you know? No, 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 not the white. There's a line. It's a special line. Oh my gosh. You guys are killing me. What do inverses always reflect across? What line, everybody? No, they always reflect across y equals x. They always reflect across y equals x. They always reflect across y equals x. You're in a loop now. All right? So you got to make sure you invert the ordered pairs. All right? So I'm just make sure I did it. 1 and a 9, 9 and a 1. Check. 3 and a 2, 2 and a 3. Check. Boom. That's it. Now this is super easy. It says, what is the inverse of negative 8? Now, what do you have to do when it says, what's the inverse of negative 8? Well, you better draw a line where y is negative 8 and see where it touches on the x. So right here, where do I go up to? 7. So at -8, my x value is at a 7, and that's all you gotta do. Wow, this is really easy. If you guys don't get 100 on this, there's probably something wrong with you. All right? But don't tell that to your parents because you'll always be special in their eyes. So last one. What we're going to do is we're going to take a look at the inverse of 1. So I'm going to do the work right over here. What's the inverse of 1? Come on, guys. Thank you, 9. What's the inverse of, sorry, what is f of -14? 11. So put 9 plus 11. So for those of you who are trying to learn online, the inverse of 1 got me to a 9. All right, so the inverse of 1 got me to a 9, but f of -14 got me to the number 11. So what am I going to write in here? I'm going to write a 20 because 9 plus 11 is 20. Now, what is the inverse of -2? The inverse of -2 is just a 10. And so that's all you guys have to do. All right? So if that was a little too exuberant or enthusiastic, my apologies, but it is my birthday, so I'm going to have some fun. All right? Now, everybody, what I do need you to do in your journal right now, in your journal, this is live, this is in the class right here, in your journal, boom, write that down, get it ready to go, please, right now. All right, so we're going to go over the steps of how to find an inverse of a linear function. So the very first thing that I would like all of my students to do is after they write down f of x equals 8x plus 1, the next thing I want you to do is we're going to go over here, we're going to write this down. Step number 1, I want you to change f of x, I want you to make it to y equals. So I want you guys right here to make this to y equals 8x plus 1. That's step number 1. Step number 2, what I would like you to do is I want you to exchange or swap. Exchange the x and the y. All right? Exchange the x and the y. So we're going to put x equals 8y plus 1. All right? Now, the next thing we're going to do, after we exchange the x and the y, now we need to solve for the new y value. We got to solve for y. So now we have to solve for this y value. All right? So basically, I'm not going to write down all the steps for that because you guys are in Algebra 2. You should know how to solve for y or a variable, but we will go over the steps mathematically. All right? So first thing we got to do is got to isolate the y, which means we got to take away 1 from this side. We got to take away 1 from this side. You can't combine those. So since we can't combine them, how are we going to write it? Just x minus 1. And what's that equal to? 8y. And the last thing we're going to do is just divide both sides by 8. Now there's a couple of ways to write this function here. I got y equals, and I got x minus 1 all over 8. But that can also be written as, in slope-intercept form, that would be considered 1/8 of x minus 1/8. So in the Khan Academy, what I'm going to do is I'm going to call this the inverse. The inverse of our original function is 1/8 of x minus 1/8. That's how I'm going to write it. But I want you guys to understand that you could also technically write it, and the Khan Academy will still count it if you write it as x minus 1 over 8. That these both will work. So if you guys have the opportunity to open up Desmos, we're going to type in both of these so that you guys see that these actually mean the same thing before we type it into the Khan Academy. So if you would, go ahead and open up Desmos, if you would, please. All right, so what I've done here is I've typed in our original function. I've typed in y equals x because all inverses reflect across y equals x. I exchanged the x and the y, and this right here is what we had before we started solving it. Right here, there's the x equals 8y plus 1. That's what we had before we started solving it. But once we finished it, we got this answer and we got this answer. Well, what do you guys notice about the green, the purple, and the orange. If you just look at the graph, green, purple, orange, what do you notice every single time I touch it? They're the exact same. So is this function equivalent to this function right here? Is the purple equivalent to the orange? It is. So what does that mean? That means technically I should be able to type that into the Khan Academy either way. So what I'm going to do right over here is I'm going to type in. Now you'll notice with the Khan Academy, you got that cool little fraction bar, okay? So I'm going to type in 1 over 8x and then put what? Minus 1 over 8. And if I do that, it should count it correct, because this is actually in slope-intercept form. But what was I telling you that you could also type in? If you wanted to, you could put this, and then in the numerator put what? X minus 1, and put it all over an 8, and it should still accept it as the answer. All right, so I'm going to go ahead and type it in this way, because I want to make sure you guys know they should still accept it. If they don't accept it, then I'll look like an idiot, but that's okay. It wouldn't be the first time. Okay? Now, if I see step by step, I doubt that they might have it in slope-intercept form. Oh, they did keep it in that. Okay. But it would have accepted it in slope-intercept form as well. All right. Let's go over here. Let's do one more. Hopefully it's a more complicated one. Good. Here's a good complicated one right here. All right. So this is the last one that we're going to do. Last one that we're going to do together right here. Could you guys please write that down in your journal? This is the last one that we are going to be working on together. Then you guys will have the rest of class to do this on your own. So step number 1, what am I going to change? I'm going to put y equals 3 over 2 x minus 11. That's what I'm going to do. Step 2, what am I going to exchange? I'm going to exchange the x and the y. So I'm going to go to Desmos real quick, and I'm going to clear out our old question, clearing it out. And we're going to type in our new question, which was y equals, I believe it was 3 divided by 2, parentheses, and then it was x minus 11. Okay, so there's our original function. I'm going to put y equals x, because we know it's going to reflect across y equals x. And then I'm going to switch out. I'm going to switch out the x's and the y's. So I'm switching out x and y. So what will our final answer? What should our final answer that we get trace? It should trace which graph? It should trace the green graph once we finish solving it. If it doesn't trace the green graph, then you guys messed up somewhere. If it doesn't trace it. All right. I'm sorry? Trace. It's you know, my favorite word in Spanish though is salsa. Salsa. It's just fun to say. It's just a fun word to say. Like you can say it happy, salsa. You can say it angry, salsa. It's just a fun word to say. Yeah, and so it's a great word for different tones. I know I'm still on video. You know, it's all right. All right. Oh, how about this? Okay, I'm gonna say the word pineapple. Okay, and then I'm gonna say salsa. Now, there's only one person that knows that if they have to listen to the video and when they hear the word pineapple, if they send me a text that says salsa, then I know they actually watched the video. I'm not going to say where the video is. All right. So here it goes. What we're going to do now, guys, we're going to solve for y. Now, I'm going to show you guys a kind of a cool way to solve for y, because what would you guys be tempted to do right now if you're solving for y? What would you guys be tempted to do? Next step, what do you guys think? I'm going to pause because nobody's thinking. Now, right now, you might be tempted to distribute this 3 over 2 to both numbers because you're used to just using the distributive property. What I'm going to tell you to do, though, if you really wanted to solve for y and do it the fastest way possible, I'm going to multiply both sides by its reciprocal. And this 3 over 2 cancels out this 2 over 3. And look what I have left now. I've got a 2/3 x equals y minus 11 by doing one step. By the way, I'm going to write a word down that you guys need to know, and I'm curious how you guys would pronounce it. So I'm going to see what you guys say. All right. So can anybody pronounce this right here? Yeah, multiplicative inverse. Good job. The multiplicative inverse. What is the multiplicative inverse of A divided by B? The multiplicative inverse is B over A, because when you multiply it together, you get 1. So right here, what did I use? I used the multiplicative inverse to get rid of that 3 over 2 and cancel it to a 1. So we're literally one step away from solving. Now, if we would have distributed, we would have had to do multiple steps. But just by knowing the fact that you can multiply both sides by 2 over 3, you save yourself a lot of work. Okay? So the last step, add 11 to both sides. And you get y equals 2/3 x plus 11. That's what you get right there. This is the inverse. So for the Khan Academy, I'm going to type in the inverse of our original function of x is 2/3 x plus 11. All right? Now, remember, you can't combine you can only combine like terms. These are not alike, so therefore you can't combine them. That's why it's 2/3 x plus 11. So I want you guys to see right now, if I write y equals 2/3 x plus 11, what do you notice about the green line and the purple line? They're the exact same. You can't type this into the Khan Academy, people. That's not that's not how it's supposed to be written. It's supposed to be written as in this form. All right? So I'm going to go over here. My bad. Try to find it. There we go. And I'm going to title it. I'm going to type it in 2 over 3 x. And was it plus 11? Is that correct? All right, plus 11. Now I feel pretty dadgum confident I got it right. Okay? So, in review, everybody, in review, what are the steps that you need to do? Change f of x to y, then do what? And then solve for your new y. And those are the steps. All right? If you want to see me, by the way, you don't have, right at this point, you guys go ahead, start working. I'm going to go ahead and do the next one, but I'm not going to speak my way through it. I'm just going to go ahead and do one more problem just because it's my birthday and I can. All right, so this is the last one I'm going to do. I'm going to do it back here. The class is working. Some of them might be paying attention. Some of them might not be. I'm going to put y equals 5 parentheses x minus 2. First thing I'm going to do is I'm going to switch out the x and the y. X equals 5 parentheses y minus 2. So I switched out the x and the y. Now, what I'm going to do is, once again, I'm going to do that thing called the multiplicative inverse. So I'm going to multiply both sides by 1/5. So if I multiply both sides by 1/5, that 5 cancels out that 1/5. So here's what you're left with. 1/5 of x equals y minus 2. And then all I got to do is add 2 to this side and add 2 to this side. And I get y equals 1/5 x plus 2. And that's what I'm going to type in right here. Now, I am going to type this into Desmos so you can see that it actually does work. So let's go over here to Desmos. All right, so here we go. I'm going to go and type in our original function, which is y equals 5 parentheses x minus 2. All right, and that reflects across y equals x. Now look what happens when I exchange the x and the y. Exchange the x and the y. So that's what I'm trying to find, okay? And my final answer that we found is 1/5 x plus 2. So look, we put y equals 1 divided by 5 x plus 2. And you'll see that, hey, that's what the inverse is supposed to look like. So I did find the correct equation because the blue and the green match. So I know I feel very, very good, very confident. I'm going to put 1/5 x plus 2. And that will allow me 1/5 x plus 2. Okay? And so that's what you're doing. I hope this video was helpful. You have a wonderful day and a wonderful life if I never see you.